So this is a presentation that is not going to focus on donors. It's not going to focus on cold or warm list donors. It's going to focus on a private company and thinking about how to use private enterprises to give more money to your charity. So this is probably the most risky field experiment I've ever done. And in opposition to David's work, this experiment finished about 37 days ago. An 8-month experiment, and I received the data about a week ago. So any comments that you have and suggestions will be very greatly received. So the problem that I'm going to tackle head on is thinking about the large externality that we face from flying. So when you fly, the carbon cost, the social cost of carbon, is not incorporating the price of flying, both on the demand side and the supply side. So we want to think about innovative ways to try to internalize that externality without changing a carbon tax, because a carbon tax is very unlikely to come in right now for the next maybe 10 years. There may be a cap and trade system in the airline industry, but that's not very likely in the next year or two. So thinking about ways in which we can internalize this externality is obviously very, very important on the policy level. And as you can see, this was 4 p.m. Central Time a few weeks ago. And at that second, there's about 10,500 flights around the world. That varies between 4,000 and 14,000 at any point during a given day. So there's a lot of emissions that come as a result of flying. It's about 2% of world emissions comes from the airline industry. That goes up to about 3.5% when you incorporate the fact that these emissions take place at a higher level in the atmosphere, so they cause more damage. But also, the airlines themselves actually care about fuel costs. Fuel costs are about between 35 and 45% of the operating costs of the business. And many airlines spend much, much over $1 billion a year on fuel. So we have this public policy objective of trying to internalize the externality, and you also have the airlines thinking about how do we actually reduce the costs of flying itself. So what we want to understand is how do you actually get airlines to be more fuel efficient? That's the main thrust of this research. And there's no research out there on causal field evidence on what changes fuel efficiency. We have some work going on right now with Hunt Allcott and others thinking about how do you give people the right information to choose more efficient cars. But we have no real evidence about how it actually changes fuel efficiency. But what's great with the airline industry is the fact that average CO2 emissions per passenger has dramatically decreased over the last 50 years. We've seen a 70% reduction in CO2 emissions per passenger. So there's been technological advances that have happened over the last 50 to 55 years. But when it comes to the behavioral side, we don't really know how to change the behavior of the agents in these airlines to actually make the airlines more efficient when it comes to fuel. And the reason that probably there's been no experiments so far is that airlines are highly unionized, both on the captain's side all the way down to those who fuel the plane. Okay? So it's a heavily unionized industry, and doing experiments is actually quite difficult. So thinking about how do you incentivize both pecuniary or non-pecuniary these agents to become more efficient, it involves large contract costs. Going through the unions, trying to get captains, trying to get agents in the industry to actually be incentivized on performance-related pay for fuel, it's never going to happen. The contract costs are so high. So what can we do as researchers to help this industry? Now, without changing the base rate, without changing performance-related pay, what do we know that's out there that can help organizations to change the employee behavior, the internal labor market? And actually, very little. We know very little in the field in terms of how to change employee behavior. There's some research done by many researchers, both in the developing and developed world, where giving people some sort of status rank incentive by telling them, well done, you're a good employee, give them a trophy, give them a star, that seems to improve productivity. But then when you put people into a contest or a tournament, there's mixed evidence about whether that actually improves productivity or not. So we don't really know, with complex tasks, like in the airline industry, going beyond envelope stuffing, going beyond inputting data into Excel for researchers, we don't know, actually, beyond looking at financial incentives, how to change behavior. I'm going to focus on Alex Imas' work, who's sitting in the corner over there. Last year, presented a really cool experiment where he tried to get people into the lab to provide more physical effort. And he randomized them into actually receiving a financial incentive or a pro-social incentive. And by pro-social incentive, I mean, if you do the task, we'll donate money to charity on your behalf. Okay? And what he found is that just by giving the charity had a higher effect on effort than the private incentive, but people were not sensitive to the price of that given to charity, but they were responsive to the price of the individual amount that they receive not going to charity. So we have a nice lab experiment that shows us maybe we could use pro-social incentives in the workplace to try to motivate individuals to change their behavior. And actually, we see this in the field, not in the field, but we see it in corporations already. Amazon do it, Peapod do it, Mac do it, Doing Good do it, Budgeons do it. A whole host of organizations say, if you buy our product, we'll donate to charity. Okay? That hasn't been tested. Maybe internally, maybe Amazon have done an experiment, and maybe it works. So I'm interested to see how we can incorporate both this theory about pro-social incentives and the real-world application. Now, we partnered with an airline in Europe that, as I said in the outset, cares about fuel efficiency, wants to reduce its fuel costs, and might have a desire to actually have good PR about reducing CO2 emissions as well. So we wanted to see how captains, those who actually fly the plane, actually what they're trying to maximize when they fly. So we did a number of interviews with these captains to understand what are they maximizing when they're actually flying their plane. And we came up with sort of 3 reasons why they are flying their plane, essentially, in a way that they do. And there's 3 reasons. It's safety, it's fuel savings, and it's effort. Okay? So we found that the airline captains really care about getting to that destination in one piece, obviously. But that involves some effort in terms of how much fuel that they take onto the plane. It also depends upon what aircraft type, whether it's a 4-engine or a 2-engine plane. It depends upon where you go in, the weather at that time, and so forth. They also care about fuel savings. We actually did get them in. It's a very focus group exercise. They said we care about fuel savings. Because we say if we can actually waste a lot of fuel, it's more likely that this airline is going to be in financial trouble. And captains are responsible for a lot of the fuel that goes onto the plane. And then lastly, it's the effort to be fuel efficient or not. So there's 3 behaviors that the captain is responsible for when he or she flies a plane. And those 3 behaviors are the zero fuel rate calculation, efficient flight metric, and reduced engine taxiing. And I'll come into what those 3 things mean right now. So zero fuel rate calculation. When a captain enters the airport, he or she is given the flight plan for that flight. And he or she is told how much fuel he should put on. This is between 2 and 7 hours before the flight takes off. So it takes about 90 minutes to 2 hours to fill up a 747. So when he or she receives this flight plan, he has to make a phone call down to the engineers and say, I want to put on this much fuel onto the plane. Okay? And that flight plan incorporates enough fuel to get to your destination, plus the 3 nearest airports, just in case that airport is closed for some reason, and some. And that sum is It's not directed by any agency. It's just the organization itself feels that it wants to be a bit averse to risk and therefore have more fuel. When the captain then gets into the cockpit, the weight of the plane is measured. And just like a grocery receipt coming out of a till, the captain gets a grocery receipt on how heavy the plane is, has to compare that to the flight plan, and then work out how much extra fuel he or she needs to put on for the extra weight put onto the plane. And then how much extra fuel he or she has to put on for the extra fuel. So a double calculation that the captain has to make in his head or on a calculator. This is not done for the captain. This is across all airlines right now. So we know whether they've actually done that calculation correct. Or we know how much fuel they put onto the plane initially. So we can work out whether they should have the right amount of fuel put onto the plane. We know the weather. We know the external circumstances. The second behavior is what we call the efficient flight metric. I should mention that we're focusing on inputs, but this is the less of the input of the three that we are focusing on. An efficient flight is using the required fuel between takeoff and landing. So it's actually getting to the right altitude on time. It's using the wings and the flaps correctly of the airplane. And it's being at the right speed. A transatlantic flight between London and Newark, a captain can make up about 15 to 20 minutes if he or she is lucky. Any more than that, it's because you've got a massive tailwind behind you. And there might be reasons, both good and bad reasons, why that captain might want to get to that airport quickly. They might want to get into the bar early and sink a beer. It might actually care about the consumers getting there early. But there's risk with that because actually you haven't got a slot. So you could end up circling around the airport for quite a long period of time because you missed your slot. So efficient flight metric is something that we also observe for each flight. And the last one is when you land on a plane, you should turn off at least one of your engines. If you're on a 747, you've got 4 engines. Why the hell are they on when you're being taxied in? So we also have a metric about whether that captain per flight turns off at least one engine. Okay? So these are the 3 behaviors that we're going to focus on in this paper. And we're going to look at, our ultimate objective is to look at how pro-social incentives impact on the behavior of captains across those 3 behaviors. But to have pro-social incentives, you need a target. You've got to give them some sort of target that they can reach to actually receive this pro-social incentive. But if you give a target, you give them information on how well he or she is doing. Okay? So those are the 3 treatment groups that we have. We have control, which is business as usual. You just get on with your daily job with no information. Treatment group 1, they receive monthly feedback on how well they're doing on those 3 behaviors. Treatment group 2 is the same information as treatment group 1, but we create an exogenous reference point for each captain based on their baseline of those 3 behaviors. And treatment group 3 is the same information as 1 and 2, plus we'll donate £10 to charity per target that you hit per month. Okay? So it's a relatively low incentive that we give for these individuals who are on a lot more money than that, obviously, per year. These are captains who are been with the airline over 15 years. So this is what the 4 sort of bins look like. So if you're in treatment group 1, you receive information. Treatment group 2, information plus targets. And in 3, it's the whole suite. Okay? So what we are interested in is really what is the impact, really, of the pro-social incentives being used in this company. So we run a frame field experiment with this airline. So all of the captains knew that they're part of this experiment. Okay? It's really, in this area of highly unionized, you just cannot get away with doing a natural field experiment. So it's a frame field experiment, but no selection bias. So everyone had to take part in it. Okay? So we were sending monthly feedback forms to their home address. If you're in treatment group 3, you receive the actual voucher saying you donated to charity. And they could choose a charity of their choice from a list of 4 that the airline was currently donating to. But we defaulted them into the chosen one of the airline if they didn't make a choice. This is what treatment group 1 looks like. This is the letter they receive going back to their home every month. We tell them the result of the zero fuel weight calculation, so how good they made a calculation when they're in the cockpit about how much fuel they should put on. We told them the result of whether they hit their efficient flight metric. And then lastly, we told them the result on reduced engine taxiing. Simple information, and we said, we'll keep you updated on a monthly performance for the next 5 months, and if you have questions, email us. The second treatment group, the same thing, but we just told them it's a target for each metric. And that's 25% above baseline, and we just said whether you missed or achieved that target and your overall outcome. That was sent every month. And then the third group was the donation to charity. And we just said whether you missed your target and missed out giving to charity and achieved your target. And again, same information below. Okay? This was the treatment. We sent this every month for 8 months to these captains. On the back of this letter, we give them actually what we mean by 3 behaviors. So everyone had full information about how we measure these 3 things. Okay? This is the distribution of the behaviors before the experiment started. Now, there's no reason why the mean of the zero weight calculation is around 45%. It should be a lot higher. There might be extreme circumstances with really bad weather that we didn't have in the flight plan, but they should be having higher than that. Again, efficient flight, the average is about 38%. Okay? And when it comes to reduced engine taxiing, there are some airports where you're not allowed to turn off one of your engines, but in most airports you are, but we've still seen a lot of people who actually don't turn off their engines. Okay? So what we did, we had a randomized control trial. We created quadruplets of pilots who were identical across the 5 things that we blocked on, which is the 3 behaviors, number of engines, and the flights per month. The randomized was done in 2014. We started in February 2014, and they finished last month. I'll move on quickly. This is just the randomization. You can see there's no significant differences across the sample size, the 3 behaviors, number of engines, average age, and the years of service with this airline. That's the summary statistics, and I'll go straight into results because I know time is short. So this is the reduced form results. Over an 8-month period, the 0 here is standardized for the control, for the baseline, after the experiment started. So this is like a difference in difference estimator for all of the groups. And what we find is that we haven't really moved the needle significantly for the zero fuel weight calculation. We have somewhat for the efficient flight metric for the charity group, and that's in green. And then when it comes to the reduced engine taxiing, we get this massive effect across all of the treatment groups. Okay? So right now, we have no significant difference between giving to charity and just creating this target, this exogenous target. But we have a difference between these 2 groups and the information treatment across the 3 behaviors. Now, there's a lot of heterogeneity in this data set. So we look at, I thought we're going to get the largest margin effect of those those worst performers. I say this is controlling for all of the things that we blocked on and all the things that we balanced on as well. But we need to incorporate weather effects that we haven't done right yet. But when we look at the top half performers versus the bottom half performers, we actually see a lot of the gains coming from the top half performers. Those who, before the experiment, had higher levels of those 3 behaviors than those who were below. We see an overall effect for reduced engine taxiing for both groups. But what's quite nice is that the charitable given effect is slightly higher for efficient flight and the reduced engine taxiing. So we see quite interesting heterogeneity there. It's not a lot, but it's something quite interesting going on. This is the really nice effect. And this will allow us to actually improve the program over time. This is, for each of the 8 months, what's the treatment effect in the first week after receiving the report to your home? And this is the 3 weeks after that first week. And what we find is that the lion's share of the treatment effect is coming through the first week after they receive this flight report. It's a real weird result of efficient flight, really backfiring, and these are all significant at the 95% level. Obviously, we see the reduced engine taxiing remain significant over time, so we really have changed their attitudes and their behaviors about reduced engine taxiing, but not for these other two metrics and behaviors. So I know I don't have much time, so I'll just quickly go through age. So this is the distribution of ages with this airline. And what we see is that the pro-social incentives and the targets work really, really well for the elderly, those between 55 and 64.
Hey,
Apologies. It's all relative, John. It's all relative. The middle ages, it works quite well. But what's quite interesting is the young ones. That for the zero free weight calculation and the efficient flight, nothing seems to be doing it for the young ones. And so when you fly with the first officer, and the first officer wasn't part of this experiment, only the captains. But usually, the elderly ones give a lot of the older ones give the reins to the first officer when they fly, and the captain sits back. So I would have thought the opposite result would have been here, but we really are having the largest effect for the older population in this result. But this is the first cut of the data. I've only seen it for a week, and there's a lot of things that we can do. So we're obviously going to put field conservation estimates to actually show the bang for the buck. We spent an average about £100 per captain on charitable incentives, and if we believe the engineer estimates from this, we might have saved the airline millions of pounds of fuel. We will look at the complementarity or substitutability of the three behaviors. We got to put in a lot of the time-varying effects. And we're also doing a survey right now with all of these captains on listing their risk and social preferences, because those are the two important parameters in our structural model that we hope to estimate. So the upshot is this is the first foray into field experiments in fuel efficiency. It's a complex job setting, but you can create the right incentives, non-pecuniary or pro-social, to change behavior. And what's quite interesting from your perspective is that many private companies already give to your charities. They donate significant amounts to you. You can actually frame the conversation in a way to get more from them if you link those pro-social incentives to their productivity. And that is something that I'd like to focus on for the next few years. And since this experiment, many other airlines now want to do this because fuel costs are massive for these companies. So, and a lot of these airlines, they employ military personnel. And the military charities are really highly sponsored by these airlines. So thinking about how to use these charities that these military personnel really care about is something that we're going to focus on in other field experiments. So thank you for your time and your patience. I hope this is quite interesting for some of you.
Thanks, Rob. Thank you. Good. Go ahead. If anyone else has a question, please raise your hand.
Hi. So from your experiments, we probably can see that making the charity component to be a incentive for the captains to do better is not doing better than the target group. So what do you think would be the problem here? And my intuition is like, if you're asking people to reach some performance point and giving them incentives to do good, if they don't reach the point, then they can just very easily justify it, say, oh, I'm just not, they can easily justify their lack of performance by saying, oh, I'm just missing this time to do good. And instead, what I was thinking is, if you can make an accumulation of their charitable donation by reaching the performance point and compare them socially, if that's going to change the game.
Okay, yeah. So on the social side, that was one of the first things that we put to them as an idea, but they do not want to compare captains against each other. They feel very uncomfortable about doing that, and there's mixed evidence about whether that works or not. So some airlines, not the one I partnered with, but some airlines do this, but it totally backfired in the sense that it came out to the public because these captains weren't happy, and a bit like what Uri was saying, some of these captains that are consistently in the bottom rung of the ladder are not going to be happy and go to the newspapers and say, hey, like these are actually making me trying to be more fuel efficient by putting me in comparison to my peers. So that hasn't worked quite well in terms of a good PR for individuals. But we want, this is one experiment where we fix that target. It might be the fact that if we had a target slightly more ambitious, it might have not worked. If it was more sensible and it was like 10% rather than 25%, that might be more effective. But again, the charitable incentive, that also might be important. The actual level of that could be important. Now, Alex's study suggests that that's not important in the lab, but we want to test that in the field. So that's what we're doing next. We're trying to vary that charitable incentive to see how actually important people's price sensitivity is to that charitable giving. But I think this study actually provides more questions rather than answers, I think.
Okay, we have a question back there, and well, maybe we have Holland calling again, Rob. Adrian, thank you. Wow, what a nice study. Thank you, that's nice to say that. But, one question, but always comes. Just ask an academic. One question, are you worried about interference between treatments that pilots in different treatments discuss received feedback with each other? So I think it's kind of a two-part question. One, are you nervous about pilots talking about the different treatments that they're in? And then point number two, talking about the feedback that they receive from the treatments.
Yeah. Okay, so that's a good question. So when it comes to the first part of that question, when we looked at the data between when we sent out our first letter to the captain saying, you're going to take part in an experiment with these 3 behaviors, everyone did better that next week. So there's a massive experiment effect going on that people knew was an experiment, and they changed their behavior because they're being watched. So that was one of the largest effects that we've seen, is when the experiment started, this airline have never seen such good results just by announcing the experiment. And the company that actually gives the data to the airline were like, what the hell are you doing with these captains? Because they're actually behaving really quite well. So yeah, there was definitely some sort of experimental effects going on, or Hawthorne effects. And they might have been talking to each other. That could be true. But the information that we have is personalized to each captain. So if another captain saw that information, he or she couldn't learn a lot from it because it's not actually directly related to his or her behavior. So I'm more concerned about the frame and field experiment element to this rather than the contamination between treatment groups.
Okay. Go ahead up here.
So my question is, I wonder if it is ambiguously pro-social for captains to do these behaviors, if they might balance safety against fuel efficiency. So I wonder whether there might be some possibility of a reaction in the opposite direction from some pilots who think, oh, the company just cares about money, it doesn't care about pilot safety, but I care about pilot safety, and some other things that you might have going on because of that kind of a thing.
Yeah, okay, it's a good question. So when it comes to fuel, you don't want a captain filling up the tank, 100%, for some airports, because the runways are so short that it takes you longer to get up, and the likelihood of crashing actually increases. So what we are trying to incentivize is the correct amount of fuel. We're not saying you should actually cut down to 0. We're saying we should put on what the flight plan suggests and then incorporate the extra weight that you put on the plane. So we're not suggesting you should come down to any safety standards that compromises safety, but we're trying to get them to be as accurate as possible. Because that second calculation, captains don't really like doing it. So that's, I think, the first part. The second part is we had, for each of the treatments, we had an email address that they could send their comments. And for the first month, we had more than a dozen captains saying, you have not calculated this correctly. I perform well on all of these metrics. You must be something wrong with your data. And then when we got back to them saying, no, we actually have observable data on this, a lot of them didn't believe it. They think what they're doing is fuel efficient. So these are all alpha types, type A guys. We got 6 females in this study group. They think that they are right. And we got some emails saying, thank you for this information, it's helpful. But more of the emails were on the negative side saying, you are incorrect, even though we have observable data on whether they did the information, whether the behaviors or not.
Okay, right down here in the front.
So one thing that's really interesting about the way you set this up is that when I think about prestige categories for donations, often, like they said, like $10,000 gold circle, blah. And my impression of those is that those amounts are set in accordance with what the charity needs, right? We need big grants, and so we set that number, and we value gifts at that amount because that best serves our needs. The targets that you give people here aren't really so much about what my impression is that they're not so much about what sort of the world needs in terms of carbon so much as they are about what you should be able to do, right? And that people clearly get pretty wrapped up in like, I was really good at reaching that target. And so it makes me wonder whether or not prestige categories could be productively reframed to people so that they're not about meeting the charity's standards for what is a good donation, but can we define levels of prestige based on whether or not you are doing as much as you can in this space? Because that people maybe just get more personally invested in that.
Yeah, okay, so in the charitable group itself, we give them the option of being anonymous or not to the charity. I think about 1 or 2 were anonymous. The rest of them wanted their name in lights given to the charity, and the charities love this experiment.
Yeah.
Because they're like, wow, you're giving us thousands of pounds to actually do something good for the world. So it kind of linked up the incentives for the private company, the charity, and the research in this case.
Yeah.
So that triangle was like perfect for this experiment. But getting the right level of incentives and thinking about how do you engender the captains to actually accept this type of treatment, it's tough. It's tough. These guys have not had anything like this in their life. They are their own autonomous agents. They have very little interference from airlines, or any airline. These guys are autonomous, and they get what they want. So when someone comes in and say, you're not doing so well, they're shocked by it.
Yeah, and this is just nice, because then you get to play on that kind of autonomy. Like, now I'm satisfying myself. I'm competing against myself as opposed to sort of trying to satisfy someone else's demands of me. So
yeah, there's a lot more to be done.
The question is it's a bit like, what should the bin levels be? And then if we compare that to exact reporting, this is a bit like it's moving toward exact reporting. And then can we think about using science to, first of all, generate the correct number of bins, the correct spacing of bins, and then when exact reporting makes the most sense? So I think that's sort of where you're going. Is there a way that we can think about calling even the smaller donors the gold donor, if it's based on their capacity or their marginal changes from 3-year period to 3-year period or some such? And I think that's right. I think the way I think about the study as well is that many of us are about providing public goods. And we think that we need to raise money to provide more of the public good. Another way to think about that problem is, can we go to spaces in our economy and think about using incentives, whether they're monetary or non-monetary incentives, to go into those spaces and affect behavior to provide public goods that way. And it's in a way that maybe you can use charity like we tried to here, and that's the link with many people in this group. But the broader story here is, if we want to make the world a better place, we need to think hard about where's the most efficient place to provide public goods. It might be getting workers, when you think about climate change, one of the greatest public goods that we face as humankind. It might not be to generate research dollars to estimate another computable general equilibrium model that shows the Earth is going to explode if we triple the amount of carbon emissions. It might be, can we come up with ways to get workers to recognize the externalities that they're imposing on society and to internalize those externalities and then behave in certain ways? That's the way I thought about framing this type of paper with this sort of audience. Many more ways than just generating volunteer hours or charitable dollars.
I'd just say as well, for these type of experiments, getting IRB is the most important thing ever. Because if there's a crash, like, you're going to be, related to. So doing this experiment, obviously, at the Malaysian airline disaster, and on your phone, you get updates, and it's like air crash. I'm like, oh my God, please not. Please don't be.
Yeah, I hope that's not one of ours, and the guy's trying to get $10 more for charity, and he took off half of his fuel. And he got into an extra headwind. He just kept making it across the Atlantic. John List and Rob Metcalfe, you're out of business. So that's exactly right. Obviously, we're not going down that route. Robert, thank you very much. Uri, Robert, and David, audience, that was tremendous. Thank you for a very insightful discussion. Thank you.